Hello everyone, I'm Paul and today we're solving problem 1717, maximum score from removing substrings. This one is medium, and here we show you my intuition, approach, and efficient solution. We are given a string s and two integers x and y. So let's say we're given this. Here we have the string, and here we have x and y. And our job is the following. We can do these two operations any number of times. The first operation is we can remove the substring AB any number of times and gain x points. Or we can remove the string BA any number of times and gain y points. And our job is here. We need to return the maximum points we can gain after applying the operations. The main observation here is that it's different to start removing substrings with AB from start removing substrings with BA. So it's different to start using these points from start using these points, because we are trying to get the maximum points we can gain. So the most intelligent thing we can do here is to start removing the substrings for the maximum amount of points. In this case, BA. BA corresponds to y, and here y is greater than x, so the most intelligent thing here is to start with this. Remember, y corresponds to BA and x corresponds to AB. So for now we can forget about this part and we will focus here. And whenever I see something like this, meaning we are trying to remove every occurrence of a substring in a string, meaning we have a string, let's say this is a string, and we are trying to remove every occurrence of this substring. And whenever I see something like this, I think about stacks. And remember, in stacks we see the pattern last in, first out. So just to be clear about this description, whenever we find BA, in this case, for example here, we can remove this and we add 5 to the result. And we do the same every time with BA because we are only focusing here. And then we are doing the same with AB. So for example here we have AB. Then when we are here, each time we find an AB, we remove this and we add 4 to the result. And at the end, the result for this example will be 19. And just to be clear, this will be the final string after all the removals. So now I will show you how to implement this approach, first with this part and then with this part. So first we are here, given that y is greater than x, we start with y. And remember, in y we are looking for BA. So the approach will be the following. We are iterating this from left to right with an I pointer from index 0. First, the stack is empty and the result initially is 0. We start with C, and given that the stack is empty, we add this to the stack. Now we update the I pointer and we are checking if the last element in the stack plus the current element equals our target, BA. And in this case, this last element is C, the current element is D, and this is not equal to BA. So we continue. But first we add this to the stack. So now the stack has this. Next we are here and D plus B is different from BA. So we add this to the stack and we continue. Next we are here and BC is different from BA, so now we add C to the stack and we continue. Next we are here and CB is different from BA, so we add B to the stack and we continue. Now we are here and BB is different from BA, so we add this to the stack and we continue. Now we are here and BA is our target, and this is the important part. Here we found our target, so we need to add something to the result, and we need to add the value corresponding to our target. So in this case we add 5 to the result, and we need to update I, meaning we don't want to add this to the stack, and we also want to pop the last element from the stack. So we pop this and we just continue. Now we are here. The last element in the stack is B, plus the current element we have BA, and BA is our target. So we do the same here. We need to add the corresponding value to the result. So the result is now 10, and we want to continue and pop the last element from the stack. Now we have an A here, so the current string is C plus A. This is different from our target, so we can add this to the stack. Now we have an A here, and we continue. Now we have a B. The current string in this case is AB, which is different from BA, so we add this to the stack and we continue. Now we are here. The current string is BA. This is our target, so we add this to the result. The result is now 15. We don't want to add this to the stack. We pop the last element from the stack and we update the I pointer. Now we are here. The current string is AB. AB is different from BA, so we add this to the stack. Now we update the I pointer, we reach the end. Our result up to this point is 15, so we will store this 15 in a new variable. We'll call this output. This is currently 15, and our string is no longer this. Now our string is this stack. This stack includes every remaining character. So now we can use this stack to do the exact same process with this. So now instead of working with a string, we are working with this stack. The result will be 0 again, and we will have a new stack which is initially empty. And remember, right now we are here, meaning we are looking for AB. We can forget about this now. So if we do the same here, we start with an I pointer here at index 0, and first the stack is empty, so we add C to the stack and we continue. Now we are here, and the current string is C plus D, and CD is different from our target AB, so we can add this to the stack and we update the I pointer. Now we are here. The current string is DB, and this is different from our target, so we add this to the stack and we continue. Now we are here. The current string is BC, which is different from the target, so we add C here and we continue. Now we are here. The current string is CA, which is different from AB, so we add A to the stack and we continue. Now we are here. The current string is AB, which is equal to our target. So here we do the same as before. We add the corresponding value, meaning 4, to our current result. So this is now 4. And we pop the last element from the stack. We update the I pointer. We reach the end. So now this is the current result for this target. So we add 4 to our output. So the output is now 19. And now we reach the end and we return this. So this is it for the approach. First, we are checking what is the larger value among y and x. And we start with the corresponding substring for the largest value. And we do the corresponding filter in the original string. And then we move to the second substring and we repeat the same process. And this is how we get our maximum output, the maximum points we can gain, and we return this. Time and space complexity for this approach will be big O of n. And now let's go with the code and hopefully you will get the idea. Here we want to use the same logic 2 times, so we will create a function and we want to be able to transform the original string and to use that string from the function. So first we'll say self.s is s, and now we will have a variable op. This corresponds to the current operation, and this will be initially ab if x is greater than y, else it's ba. Now our function, will call this solve, will take an argument, an operation, and initially the result will be 0. We'll have an empty stack, and now we can say for I in range length of self.s. First we want to check if we don't have anything in the stack, or the current string, meaning the last element in the stack plus the current element, is different from our target, we add to the stack the current character. Else we need to pop the last character from the stack and we add the corresponding value to the result. So first we say if not stack, or stack at -1, meaning the last character in the stack is different from the character at operation 0, or self.si, meaning the current character is different from the character at operation 1. In this case, we add to the stack self.si. Else, meaning if we found the target, first we need to pop the last character from the stack, so stack.pop, and now we want to update the result, so result plus equal x if op equals ab, else y. And now after this loop we want to update the string, so we will say self.s is join stack, and finally we return the result. So now with this function we can say the output is initially solved with the corresponding operation, with this operation here, and next we can change the operation to do the second part, so op equals ab if op equals ba, else ba. Now we can add to the output solve with this new operation, and finally we return the output. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.